In previous lecture, I already discussed one-to-one functions. Today, I will discuss onto functions. First definition of onto functions. A function f from a to b is called onto or a surjection if and only if for every element b belongs to b, there is an element a belongs to a with f of a equals to b. A function f is called surjective if it is onto. Means for every elements of set B there should be a pre-image. And onto functions possible if cardinality of B is less than equals to cardinality of A. It's just opposite of one-to-one. In case of one-to-one, one-to-one functions possible if cardinality of A less than equals to cardinality of B. Means number of element in A less than equals to number of elements in B. But here in case of onto, number of elements in set B should be less than equals to number of elements in set A. If both A and B contain same number of elements, then one-to-one function is also onto and vice versa. In case of one-to-one, two elements cannot map to same elements of set B, but here two elements of set A can map to one element of set B, but every elements of set B should be image of some elements of set A. Let this is set A, this is set B. Here let A, B, C, D. Here 1, 2, 3. Let A map to 1, B map to 1, C map to 2, D map to 3. It's a onto but not one to one. As for both A, B, its image is 1. F of A and F of B both are same. So it's not one to one but it's onto, as all elements of set B are image of some elements of set A. If number of elements in set A and set B equals to n, then number of onto functions possible from A to B is n factorial. How many one-to-one functions possible? I already discussed in previous lecture. That is also n factorial if number of elements in set A and set B are equal. And if A cardinality equals to m, B cardinality equals to n, and m is greater than n, then number of onto functions possible from A to B is n power m minus nc1. This is stands for combination n minus 1 power m plus nc2, n minus 2 power m minus nc3, n minus 3 power m up to minus 1 power n, nc n minus 1 1 power m. This is the formula for number of onto functions possible from set A to set B. And how many one-to-one functions possible? I already discussed in previous lecture. It's permutation of n, m, or you can say permutation of B cardinality, A cardinality. Let's see some example based on number of onto functions possible. First example 8. Let A cardinality equals to 6, B cardinality equals to 3. Then how many onto functions possible from A to B? Here A cardinality equals to 6 and B cardinality equals to 3. Number of elements in set A is greater than number of elements in set B. So we can apply this formula. If number of elements in set A equals to number of elements in set B, then it will be simply n factorial if both are same. Here what is n? N equals to 3 and m equals to 6. So 3 power 6 minus 3c1. Then in place of n we'll write 3. 3 minus 1 power 6 plus 3c2, 3 minus 2 power 6. Here we will stop as we need to continue till nc n minus 1. Here n equals to 3, so 3 minus 1, 2. Now 3 power 6, it's 729. Then 3c1, it's 3. 3 factorial divide 1 factorial multiplication 3 minus 1 factorial. So 3 factorial can write 3 multiplication 2 factorial divide 3 minus 1 is 2 factorial. So 2 factorial will cancel, will get 3. 3 multiplication 3 minus 1 is 2. 2 power 6 is 64. So 3 multiplication 64 plus 3c2. 3c2 is 3 factorial divide 2 factorial, then 3 minus 2 factorial. So 2 factorial will be cancelled. Now 3 divide 1 factorial, it's simply 3. Then 3 minus 2, it's 1. 1 power 6, it's 1. So plus 3. Now simplify 729 plus 3, it will be 732 minus 3 multiplication 64, it's 192. After subtraction, we'll get 540. So answer will be 540 onto functions possible from set A to set B if A kernel equals to 6 and B kernel equals to 3. Next example 9, let A kernel equals to n and B kernel equals to 2. Here n is greater than equals to 2. If n value equals to 2, then number of onto function will be simply 2 factorial. If n value is less than 2, then onto functions are not possible. If n value greater than equals to 2, then only onto functions possible. So it is saying the number of onto functions possible from set A to set B is dash. So it will be 2 power n minus 2c1, then 2 minus 1 power n. 2 power n, 2c1 will be 2 factorial divide 1 factorial and 2 minus 1 factorial. It will be 2. Then 2 minus 1, it's 1. 1 power n, it will be 1. So 2 power n minus 2. So number of onto functions possible from set A to set B equals to 2 power n minus 2 if A kernel equals to n and B kernel equals to 2. Next example 10, how many way we can assign 5 employees to 4 projects so that every employee is assigned to only one project and every project is assigned by at least one employee. So here there are 5 employee and 4 project. Let this is one set employee and this is another set project. There are 5 employees, so let's take E1, E2, E3, E4 and E5 and 4 project. Let P1, P2, P3, P4. Here it's written every project is assigned by at least one employee, means it can assign to multiple employee. So it's a onto function and it is asking how many onto functions are possible from employee set to project set. So here m equals to 5 and n equals to 4. Now substitute in the formula. So n power m, it will be 4 power 5, 4c1, then 4 minus 1 power m, it's 5, then plus 4c2, 4 minus 2 power 5, minus 4c3, 4 minus 3 power 5. Now solve this. So 4 power 5, it will be 1024. Then 4c1, it will be 4 factorial divide 1 factorial, 4 minus 1. 4 minus 1 is 3 factorial. So it will be 4. Then 4 minus 1, it's 3. 3 power 5, it's 243. Next 4c2. 4c2 is 6. 4 factorial divide 2 factorial, multiplication 4 minus 2. So 4 factorial divide 2 factorial, multiplication 2 factorial. 4 factorial we can write 4 multiplication 3 multiplication 2 factorial. Now 2 factorial will be cancelled. This 2 will be cancelled with 4. Here 2. 2 multiplied 3 is 6. So 6 multiplication 4 minus 2 is 2. 2 power 5 it's 32. Minus then 4c3 it's 4. 4 minus 3 is 1. 1 power 5 is 1. Now simplify this, we'll get 1024 minus After multiplication, we'll get 972 plus 6 multiplication 32, 192 minus 4. Now add all positive numbers. So 1024 plus 192, it will be 1216 minus, then 972 minus 4, it will be 976. Now subtract, will get 240. So 240 way we can assign 5 employees to 4 projects, that every employee is assigned to only one project and every project is assigned by at least one employee. Means one project can be assigned to multiple employees. Next example 11, it's for identifying a onto function. Let f be a function from a, b, c, d. One set contain a, b, c, d to 1, 2, 3. Is f an onto function? Yes, it is a onto function. Let's do the diagram that you can understand. Now f of a is 3, f of b is 2, f of c is 1, f of d is 3. This is onto as all elements of set B are image of some elements of set A. So all elements of codomain are image of domain, but it's not one to one as 3 is the image of A and B. It's not one to one, but it's onto. Next example 12, is the function f of x equals to x square from the set of integer to set of integer onto? No, this is not onto. There are some integer which are not perfect square, like minus 1, it's not perfect square. 3 is not perfect square. So f of x equal to x square from set of integer to the set of integers. So it's not onto. Some elements of set B are free. In case of onto, all elements of set B are image of some domain. As there are some free elements, so this is not onto. Next example 13, is the function f of x equals to x plus 1 from the set of integer to set of integer onto? Yes, this is onto. Also I discussed this is 1 to 1. Like f of 1 equals to 2, f of 2 equals to 3, f of 5 equals to 6, f of 10 equals to 11. So from set B, every integers are image of some integers. Like f of x equals to x plus 1. So we can say let x plus 1 equals to y. Then for every x there are different y. So it is both 1 to 1 and onto. With this I am finishing onto functions. Today I discussed definition of onto, then number of onto functions possible from set A to set B and some examples. In case of 1 to 1, cardinality of A should be less than equals to cardinality of B. In case of onto, cardinality of B should be less than equals to cardinality of A. And in case of onto, all elements of set B should be image of some elements of set A. Means there should not be free elements in set B, whereas in case of 1 to 1, for every element of set A there should be different images. In next lecture, I will discuss some diagram that you can understand the difference between 1 to 1 and onto. Also, I will discuss bijection or 1 to 1 correspondence. If this lecture is helpful for you, please like, share and subscribe. Thank you.